Okay, let's jump in. Today we're doing a deep dive into something that's, well, it's usually invisible, but absolutely essential. We're talking about environmental monitoring.
Specifically, high-stakes liquid detection. Think about data centers, control rooms, any place where a small leak can turn into a catastrophe.
Exactly. And our mission today is to really get into the weeds on one specific system, the NTI E-TLD-P25 tape-style liquid detector. It's a 25-foot powered sensor.
We're going to decode the tech specs and, figure out why engineers really trust this particular
And
device.
when I was reading up on this, I was genuinely impressed. It's so much more than just a simple wet or dry sensor. The real engineering here is all about two things, precision and this critical feature they call a continuous self-check.
Right. So at its core, the E-TLD-P25 is designed to do one job really well.
Fine water.
Find water or other conductive liquids and warn you before a tiny drip becomes a massive flood.
So how do they actually engineer it? I mean, to be reliable over a full 25 feet, the system uses this self-adhesive sensor tape.
And it has these copper fiber electrodes embedded in it. The whole thing is protected by this really durable netted cover.
And the key thing is conductivity, right? It's specifically looking for things like water or sewage.
Exactly. So it's not going to trigger for, say, a non-conductive liquid like pure oil.
And the sensitivity. That's where it gets amazing.
The precision is remarkable. The minimum puddle size it can detect is just 0.125 inches.
That's only 3 millimeters in diameter.
Think about that. It can catch a tiny leak from an AC unit overhead before that puddle even has a chance to spread towards a rack of servers.
Okay, so this is where it gets really interesting for me, the reliability part. The biggest challenge with any sensor is silent failure.
You think you're protected, but the sensor itself is broken.
Exactly. And you have zero idea. So what sets this powered version apart is the continuous tape integrity self-check.
That's the crucial feature. The system is constantly sending a signal down that 25-foot tape and back again.
It's checking itself.
It's checking its own functionality, yes, to make sure it hasn't been cut or damaged. It's like a diagnostic check on the diagnostic tool. It gives you verifiable proof that your protection is actually active.
Okay, so let's shift from integrity to logistics. How do you actually deploy this thing?
Well, it has a weather-resistant enclosure, so it's durable, and you can mount it on the floor, or more importantly, right under the pipes where leaks are most likely to start.
And what about power?
It's very low demand, only consumes 60 milliamps at 12 volts DC, and it's powered by other compatible NTI units.
That low power draw is a key detail, isn't it? It means you can easily hook it into a UPS or a battery backup.
So your leak detection stays on, even if the main power goes out.
Now, we're looking at the 25-foot model, which is priced at $955. But they have other lengths, I see.
They do. You can get it in 10, 50, and even 100-foot lengths, depending on the area you need to protect.
And looking at the purchasing details, it's pretty clear this isn't for your average consumer basement.
No, this is for serious institutional buyers. It's TAA compliant, which is a requirement for U.S. government purchasing. Think military bases, government data centers.
And they seem to stand behind it. A 2-year NTI warranty and even a 15-day free trial.
It signals a lot of confidence in the product.
So when you boil it all down, the key takeaway here isn't just that it detects leaks. It's that the whole design is focused on verifiable, self-checked integrity. The price seems high, but the cost of failure for what it's protecting is, well, it's just astronomical.
Which brings up a really interesting question for you to think about. We've been talking about the self-check feature on this 25-foot model, but what about the 100-foot version? That one costs over $2,500. What hidden risks might still remain in a system that long? What do the designers have to account for in terms of, say, signal loss over that distance, or potential breaks, or other vulnerabilities inherent in monitoring such an extended length?
A great question to end on. That wraps up our deep dive into high-precision liquid detection. We'll see you next time.